Hey guys, this is Mrs. Moon, and since I can't be here today, I figured I would help you through your assignment on logarithmic functions. So, we are looking at the fact that logarithmic functions are inverses of exponential functions. The directions here on your worksheet, everyone should have a worksheet. This is 7-3 practice, form G. And the directions in this first part are to write each equation in logarithmic form. So if we take a look at number 1, we would write log base 9 of 81 equals 2. I want to remind you that I mentioned yesterday that if you'll look at this in a circular type motion, it kind of shows you what terms go where. So we're really just rearranging the terms. So let's look at number 2. This one would be log base, this time the base is 1/4 of 1/64 is equal to the exponent 3. So this time the base, what it's equal to, and it's equal to that exponent. All right, let's look at number 3. This would be log base 8 of 512 equals the exponent 3. So again, that circular motion, log base 8 of 512 equals the exponent of 3. And number 4, log base 1/3 of 9 equals -2. Again, you get that by looking at the circular motion around the problem. Okay, problems 5, 6, 7, and 8 are very, very similar to 1, 2, 3, and 4. Pause the video now and go ahead and work through 5, 6, 7, and 8 on your worksheet. And after about 2 minutes, we'll replay the video and we'll work through some of the next section together. Okay, so now we are going to look at the next section. This is evaluating logarithms. I will remind you there's a couple ways that you can evaluate logarithms on the calculator. If you go to math button, and you scroll through the list, choice A says log base. If you hit enter on that, it pastes this on the screen and this will evaluate logs for you. You can type in base 2 of 128 and that equals 7. So to evaluate this logarithm, you can use the calculator to do that, but you got to know where to find log base. So again, let me talk about where we find log base. If you go to math, you can tap math alpha math and it just pops up. That's a shortcut to get it. You could type math and scroll through the list to find it. It's choice A, it says log base. Or you could tap alpha window and log base is the 5th choice in this shortcut menu. There's a couple ways to get log base on your calculator. So the second problem says log base 4 of 32. And so that equals 2.5. So that is 2.5. But we don't want to completely forget what this means. Like number 11, log base 9 of 27. Yes, I can use the calculator to do it. Math alpha math. Just messed up. There we go. Log base 9 of 27. That is 1.5. But let's understand what that means. That means that 9 raised to the 1.5 power equals the number 27. Okay? And let's test that. Let's just be sure. 9 raised to the power 1.5. That does equal exactly 27. So understand that this is really just an exponential evaluating problem using logarithmic notation. So number 12 is log base 2 of -32. Log base 2 of -32. Up, we got an error. says non-real answer. This is something I didn't get a chance to tell you yesterday. You cannot take the log of a negative number. Logs of negatives are undefined. Okay, and I ran out of room there, but that's supposed to say undefined. So you can't take the log of a negative because it is undefined. I'll leave you to doing problems 13 through 16. I'll just make one mention that on 14, we don't see a base. If there's a base missing, we assume that base to be log base 10. In that case, you could use this log button, it's called the common log, on the calculator. This log button of 100,000, because base 10 is assumed with the log button. It's called the common log. And so there's the answer for that one. Okay, go ahead and finish this part of the worksheet. Pause the video and then start it back up in about 2 minutes. Okay, in these problems, you're just asked to write the equation in the exponential form. So let's look at 17. Again, we're going to follow that circular pattern. Log base 4 of 256 equals 4 is going to be written as 4 from the base raised to the power of 4 equals 256. Number 18, log base 7 of 1 equals 0 is going to be 7 raised to the power of 0 equals 1. And I know that's true because anything to the 0 power always equals 1. 19, log base 2 of 32 equals 5. That's going to be 2 raised to the 5th power equals 32. And looking at 20, that one just says log of 10 equals 1. Again, I will remind you that if the base is missing, and we're using the word log, this is the common log, the base is assumed to be 10, so this is 10 raised to the power of 1 equals 10. So the base 10 is assumed whenever there is a 10, or whenever there is a base missing. So 10 to the first power equals 10 is the answer here. I will leave you to finish problems 21 through 28. Pause the video, and you'll probably need maybe 2 or 3 minutes. Okay, the next part of your worksheet asks about the graph of a logarithmic function. It says y equals log base 3 of x, and it wants us to graph and show a table. So what I'm going to do is use the calculator to aid me in graphing. Go to y equals to graph an equation. If I want to type in log base something, I'm going to tap math alpha math to get log base on my y equals screen. My base here is 3, so input a 3, right arrow, and I need to put an x into the function there. So log base 3 of x. Remember the x button is right here. Having trouble focusing on it, but it's right there beside of alpha. Log base 3 of x. Okay, push the graph button. You should not be surprised to see this really slow-growing graph. A slow-growing graph is characteristic of a log graph. It asks me to graph it, though, here on my paper using a table. So I know that I can access a table easily on the graphing calculator by tapping second graph, and it brings up a table. Now, I see at 0 there's an error, but I see at the point 1 on the x-axis, 0 on the y. Please come to student affairs. I can, plot a point there at 1, 0 on my graph. Then at 2, we're up at 0.6. How about at 3, we're up at 1. So I'm going to plot that point. That's a nice one. 3, 1. It's really hard to graph with a stylus. Okay, and let me scroll down and find another good number. It's growing really slow. Up all the way over at 9. It took it all the way over to 9 to get up to 2, so it's growing really slow. 3, 6, 9, we're up at 2. So those are some good points on my graph. So if I want to show my table, I may say that at 1, we were at 0, at 3, we were at 1, and at 9, we were up at 2. So those are some points on my graph. And now I will connect with a curve. Oh boy. Okay, and arrow. So there is my logarithmic graph, y equals log base 3 of x. This last part of the worksheet asks us to state the parent function for each logarithmic equation and then describe how the graph of each function is shifted from the graph of its parent function. So first of all, what's a parent function? We learned about quadratic functions, y equals x squared is a parent function. Absolute value functions, y equals absolute value of x is a parent function. Linear functions, y equals x is a parent function. For logarithmic functions, it depends on what the base is. So for number 30, the parent function is y equals log base 3 of x. So the very basic function that we're dealing with is the log base 3 function of x. Now, in problem 30, there's your parent function. How has this parent function shifted? Well, that minus 2 at the end of the function indicates a vertical shift downward by 2 units. So it takes this graph and it would shift it down 2 units. So that's how we would describe how it is shifted. And remember that all graphs shift in the same ways. They all behave the same, whether they're log graphs, quadratic graphs, any of them. They shift up and down, left and right in the same way. So let's take a look at 31. Y equals log base 8 of x minus 2. The parent function here, or the most basic of these functions, is log base 8 of x. That's the parent function. Now, how has that shifted? Well, that minus 2 is in parentheses. It's with the x. So a minus 2 that's in parentheses is going to be a horizontal shift, and it's going to shift this function 2 units to the right. So right 2 units is how that one is going to shift from the parent graph. Now, problems 32 and 33 each have 2 shifts, both a horizontal and a vertical shift in them. So go ahead and try those. And when you finish, please turn in your papers. Have a great afternoon. So I hope that this lesson has helped you to learn just a little bit about logarithmic functions and exponential functions and how they are inverses of each other, how you can convert between the two forms, how we can shift the graph of a logarithmic function, and how we can evaluate logarithms. So I tried to get some of students that were sitting in my room doing makeup work to participate in the video, and they refused. So I just put their picture on the end. So there they are. So how about that?